Okay, here's some guidance for the exercises on conditional probability, the homework. So for the first one, again, I assume you guys try this out. This is where we start the dry run to the midterm. It's heavily weighted in terms of conditional probability. You can take a look ahead if you want at the midterm review, and it indicates the structure of the exam. But these practice problems are the crucial ones. They'll help you prepare. And there's a number of problems from the practice problems and in the book, in the homework, that will be the models for what to expect on the midterm. So no surprises there. So those who will be keeping up with the work, you should be more than prepared. Put in the good faith effort. It will reward you like anything else in life. Okay, so here's the first one. There's three branches to start off for those who try this, right? So you start here. One, two, three. Why three? Well, there's three coins. A box contains three coins, and it says a coin is selected at random from the box. So you could either get, let's call this F, the fair coin. You could get the two-headed coin, so let's call that T for two-headed. Or you could get the weighted coin, so let's call that W for weighted. Now, since a coin is picked at random, that means they're equally distributed. So there's a 1/3 chance here, 1/3 chance there, 1/3 chance. Why 1/3? Because when you split it in three, it's 1 out of 3. So for the fair coin now, what we want to know is for each of these, what's the chance that heads appear? So I'm looking only for H. For each of these, only for H. Each of these, only for H. So that's what the diagram looks like. You could, for each of these, split them off into more branches, but you only are concerned with H, so you should try to make these diagrams as streamlined as possible. For the first one, it's a fair coin, so the chances of getting a heads is 1/2, right? That corresponds to this branch right here. 1/2 is the chance of getting heads, given that it's a fair coin. The next one, it's a two-headed coin, so it doesn't matter. It's two heads, so the chances of getting heads is 1. And then the next one, the coin is weighted, so the probability of heads appears as 1/3, so there's a smaller chance of getting heads. So there's the diagram. That's the most points on the exam. 50% for all problems involving conditional probability. Diagram, 50%. Okay, now second thing, second importance, worth less points, but still secondary importance. Find the probability question. So in this case, you're asked, what's the probability that heads occurs? Okay, it's not just H, but really what this breaks down to is there's three ways to get H. So it's really, this is equal to probability of H, let's call this H1, H2, H3. I can get H1 or H2 or H3. There's three ways of getting heads. So that ends up equaling, I got OR here, I want to add, remember OR goes with addition, but in order to add, I got to first establish that they are disjoint. Are they in fact disjoint? Well, if you choose heads from that first coin, does that mean at the same time you can choose heads from the second or third coins? No. They're separate coins, separate events, so that allows you to add. So this equals probability of H1 plus H probability of H2 plus the probability of H3. And we got to remember, it's not just each of these, but it's actually H1. So each of these has to be amended, given that it's fair and given that it's you getting the two tails, and given, etc. Yeah, that it's weighted. Okay, so what this ends up adding up to, or I should say solving towards, is if you read off the diagram, it's really 1/3. So I'm drawing from that first branch and getting a heads there times 1/2, because each of these are independent events, right? Why independent? Because there's no memory of it. My getting a heads here has no relation to my drawing that fair coin in the first place. Plus 1/3 times 1 plus 1/3 times 1/3. When you solve for this, it ends up equaling 11/3. There's no calculators on the exam, so you should start practicing this by hand and solving. The answer at the end is worth the least amount of points on the exam. Most amount of points for the diagram with correct labels, secondary points for the probability question, and then the formula, and then sticking in the equation, the numbers read off the diagram, and then thirdly the solving, which is worth less points, least points. Okay, let's move on now to the second one. So you're given an urn that contains 3 red marbles and 7 white marbles. A marble is drawn from an urn, and a marble of the other color is put into the urn. A second marble is drawn from the urn. Find the probability that the second marble is red. So there's two ways of getting reds, so that's why there's two branches here. So let's start here. I could get either, let's see, what are the two things that can happen? Well, if I draw, let's say, uh, well, let's say a red on the first draw, right? What happens? A marble is drawn from the urn. A marble of the other color is then put into the urn. So I put in a white if I draw a red first, right? And that means your chances of drawing a red decrease for the second draw. So I get a red on the first and then a red on the second, or I could have drawn a white on the first and then a red on the second. So there are your two ways in which you can get a red. Now let's list the let's label this. So the chances of getting a red from the first draw, there's again 3 red marbles, 7 white, so there's 10 total, 3/10 for getting red. But then what happens is after I draw that red, a marble is put that red is put back in the urn. A marble of the other color is, sorry, the red is taken out, a marble of the other color is put back in the urn. So a white is put in, so we still have 10 total. So now there's only 2 reds left, so the chances of getting red for the second draw are only 2 out of 10. Okay, and then for the whites, there are 7 white marbles, so the chances of getting whites are 7/10. But then after I get a white, that gets taken out and you put another red in, so there's an additional red. The second way in which I can get a red is on this second draw here. After drawing a white, there's now, instead of 3, there's 4, so 4 out of 10, right? And now the question is, what's the probability that the second marble, second R, right? So that really reduces down to the probability of getting a red on the first and a red on the second, or a white on the first and a red off the second. That's actually corresponding to what I see in the diagram. This equals, again, you can add because they're separate events, they're disjoint. Whenever you're drawing a red and a red, that's separate from, you cannot at the same time draw a white and a red. So that's the probability of RR plus probability of WR, which equals, when you read it off the diagram, 3/10 times 2/10. You can multiply these because they're independent events, plus WR. Again, you can multiply those because they're independent events. This is R and R, W and R. So it's 7/10 times 4/10. You guys can solve that and see what you get. Okay, so that is number 2. Let's now move on to number 3. And number 3 says that a class has 10 boys and 5 girls. 3 students are selected from the class at random, one after the other. Find the probability that the first 2 are boys and the third is a girl. So this one has just one branch. I get a boy, I get a boy, I get a girl. That's it, right? So probability of boy, boy, girl. This equals, since it says they're selected at random, they're independent events, so probability of, basically of this times that times that. I don't need to write that down. What's the probability? So let's write this down. What's the probability of getting the first one a boy? Well, that's going to be, there's 10 boys, so 10 out of 15 total, right? And then after you do that, one is removed from the class, so there's only 14. So the chances of getting a second boy are now 9 out of 14. And then the chances of getting a girl, there's one more student removed, so there's still 5 girls remaining. So 5 out of now only 13 students. So this ends up equaling 10/15 times 9/14 times 5/13. You can do the math on this. If you want to practice longhand calculation, it's good for you. On the exam, I'll try to make the calculations as simple as I can, relatively speaking. It's, again, the course is about concepts, not the math as such. Answers are always worth the least amount. If you just plop down answers, even if it's right, I can give you almost no points if you haven't shown the work. So please show you the work. I cannot emphasize that enough. Majority of points is showing me that you understand the reasoning and you're showing that to me. If you just say, I got the answer right, I'm telling you point blank, it's going to count for pretty much nothing. In fact, if the question is worth 20 points, I very often make the answer itself only worth 1 point. So don't worry about the math, worry about the process. Okay, here we go, last one. So you got this college, 25% are boys, 10% of girls are studying mathematics. The girls constitute 60% of the student body. If a student is selected at random and is studying math, determine the probability that the student is a girl. So there's 2 branches here. How do you know? Well, it's always the first part of the branch is always relative to the population you're talking about or the first event that occurs. Like with our first diagram, the the first thing you did is you draw at random one of the 3 coins. So that's why there are 3 branches. In this case, what's your population? Your population is either G, girls, or not G, or if you like, B, boys. Not G is B, right? Boys. So how much of the population is girls? 60%. How much then is boys? 40%. Okay? And then relative to each of these, you're asked about studying math. They may study other things, but you're only given information about studying math. So given that we're talking about girls, what are the chances that they're studying M for math? If you think about it, the given is actually what the diagram is saying. Given G, given that you're talking about girls, what percentage is talking about math? What percentage is taking mathematics? And it says here that 10% are taking math. That's kind of sad because it's sort of true. I mean, STEM and girls, there's not enough women in engineering fields, and it's not because of lack of talent or anything like that. It's very often other factors, but it's a sad fact. We need more of that. We need more, as it were, equality in representation for the STEM fields, science, mathematics, stuff that, well, matters. So the other one is given, we're talking about not G, which is, if you like, B, boys. What are the chances that they're studying mathematics? Well, it's 25%. Okay, so there's that. Now you want to know what's the probability that the student is a girl. Well, it's not a straight up question. What's the probability that the student? It says if given. If is another word for given. That's what conditional probability is about. If then given this, right? What's the probability of this given that, conditional upon that? If this, then that, right? So if a student is selected at random and studying math, so what you're saying is the probability of given that a student is studying math, you want to know what's the chances that they're a girl. So that's how you do it. Given that you're studying mathematics, right? If they're studying math, what's the chances that we're talking about a girl? So now you use the formula for conditional probability. Remember, anytime you have this slash inside, remember it reads given. So now here's the formula that you have to memorize for the quizzes and all that. It'll be on the test. You put these together, so it'll be P, R, G, and M. And then the slash becomes, when you put it on the outside, it becomes divide, like that. I use the slash there in my lectures and whatnot because the book follows the same convention. And that's only to make sure you guys aren't confused, even though it is a bit confusing. Remember, when it's outside of the PR statement, that slash means division. So you're saying that divided by the right side. So PRM. That's how you memorize the formula for conditional probability. And now you just read this off of the diagram. What does that equal? Well, what's PR, G, and M? What's G and M? It's basically this first branch. So it's 60% times 10%. Divided by, what's the chances that you got someone studying math? Well, there's 2 ways. This actually breaks down to, if you like, M sub G for girls and M sub B. So this is really equal to M sub G or M sub B, because there's 2 ways in which you can study math. This corresponds to the formula for total probability, one of the axioms. And that ugly formula is really saying nothing more than this branch plus this branch. So 60% times 10% plus the other branch, 40% times 25%. Now, while you have to memorize the formula for total probability, I'm giving you the easy way to memorize it to basically know it. It's saying this times that plus this times that, each of the branches. And that's really all that total probability is saying. When you solve this, you guys should get a number. You can do that by calculator. You should try to do it by hand if possible. Turn all this stuff in. Get the credit, but remember, it's what you're doing really is not just getting the credit, that's part of it, but you're preparing yourself for the upcoming exam. Okay, folks, see you next time.